Hi. In the previous video, we talked about ambiguous triangles, and we understand that it is possible to have different sketches of the triangle, and both triangles would fulfill the conditions given to us. Okay? So in this video, we will actually solve the problem. Okay? So here, this is the exact triangle that we had in the previous video, where angle A is 30 degrees and the side A, which is across from angle A, is 10 centimeter, and angle B is over here, and we need to find angle B, the length, the side that is across from angle B, small b over here, the blue side over here is 13. Now, given that we already know what sine rule is, this has become very easy. Okay? So I'm going to go with sine 30 degrees, so that's my sine A, over my sine A over A, which is 10. This is equal to sine of B over 13. Okay? So just simply applying sine rule. Sine 30 over 10 is equal to sine B over 13. So sine B is equal to 13 multiply 13 multiply sine 30 over 10. Okay, a lot of you guys like to just put this part, 13 times this fraction part, into the calculator, and then you tend to round it up. Right? Let's try to avoid doing that, because that actually affects the precision of our results. Okay, so what I'm going to do here is I'm just going to show the whole working here. So B is equal to arc sine, right? Arc sine or inverse sine of the whole thing, right? 13 multiplied by the fraction, sine 30 over 10. Okay, and now this is when I use my calculator. So if I put that in my calculator, I will get approximately 40.54. Right. So that is how much this angle is going to be. So this angle is 40.54. Let's put it down there. 40.54. Okay. Cool. Now, we know that there is another possible scenario, right? And let's see what is the difference here. In the previous video, we talked about due to the two different sketches, one of the angle will, for angle B, one of them will be acute, which is what we have here, and the other one will be obtuse. So let's see. Let's look at the other example. Let's look at the other sketch then. So here it is. This is the other sketch that also fulfills all the conditions that the question gave us, right? And now we need to solve this obtuse angle right there. Okay, so let's try to apply sine rule and see what we have. Okay, I want you guys to try that. Just try to pause the video and try to apply sine rule, and you will notice something weird. Okay, go ahead, pause the video, try it. Okay, so I hope you have tried it. All right, so let's actually do this together. So I'm going to have fraction sine of 30 degrees over 10 is equal to fraction sine of B over 13. But hey, that looks exactly the same as what we have here, right? Exactly the same. This line over here is exactly the same as the line I have over there. So if I continue to solve this, my B is going to be the same as what I have earlier, 40.54. And what? That doesn't make sense. And because we know that this is supposed to be an obtuse angle, right? So how do I continue from here, right? So this is why the ambiguous triangle requires a little bit more thinking. Okay, the first sketch, straightforward, apply sine rule. We found the angle, the acute angle. Now for the obtuse angle here, some of you guys might just think, hey, I'm just going to take 180 and minus 40.5, and that's my obtuse angle over here. Is that true? If it is, why? Right? Why? So I'm going to switch my screen to the unit circle. Okay, so give me 1 minute. Alright, so here I have my unit circle, and I hope by now we are all familiar with the unit circle. Okay, now just now we mentioned that the angle that we have, it was 40.54, right? That's the acute angle that we have here, 40.54. Okay, so let's go back. So 40.54, so maybe somewhere, the angle is 40.54, so maybe somewhere there. Right? The angle theta here, this is 40.54. Let me write that. This part is 40.54. I'm just going to put 40.45. Okay. And I have this point right there. Since it's a point, it's going to have some x coordinate and some y coordinate. And this is the x coordinate. I hope by now, oops, we know how to find them. This is just the cosine of the angle, right? Cosine of 40.5. And my y is simply the sine of the angle, 40.5. Okay, cool. Now, since we're talking about, we're trying to use sine rule to find this obtuse angle, right? So on the top here, I know that my angle should not be 40.5. That's for sure, right? In fact, let me change that. This angle here, I'm going to change that sign. That should not be 40.54, because we already found the acute angle. That should be an obtuse angle, right? But at the same time, sine of that obtuse angle should give me the same value as sine of the 40.5 degree angle. Look at that. This sine B, even though this is the obtuse angle, but the sine of that obtuse angle has the same value of the sine of this acute angle here. Okay, let me repeat that again. The sine of this obtuse angle over here, right? The sine of this obtuse angle will give me the same value as the sine of this acute angle here. All right. So now we're going to switch back to the unit circle, and we'll explore a little bit more there. So here it is. And the angle we're talking about here is 40.5 degrees. So I'm just going to make 40.5 degrees, following the standard position rule. So start from here. This is about 45, so 40.5 is somewhere there. And I'm going to have a point there. Right, and my theta, this is my 40.5. 40.5. Okay. Since this is a point, it's going to have some coordinate, and by now we should all be very familiar with finding the coordinate, right? So the x coordinate will be cosine of the angle, and the y coordinate will be the sine of the angle. Right? Okay, now what we have to do now is to find another angle, right? Another angle. Let's say that angle is called B2, right? Which B2, B1. Let's say this is B1. This is the first angle we found, and this is another angle, another possible angle B, but this is the obtuse one, right? So we need to find another angle B2, so that sine of B2 is the same. It gives us the same value as the sine of 40.5. Okay, now remember when we first talked about the unit circle, there were a couple of rules there, right? And one of them says this: sine theta is equal to 1. Go ahead, take out your notes. Sine theta is equal to 1. Please don't. Sine theta is equal to sine of 180 minus theta. Right? 180 minus theta. Because if they are supplementary angles, then they have the same sine value. Right? So in this case, my B2 would be 180 minus 40.5, which is what we mentioned just now, right? We kind of just took a wild guess just now, and that's actually true, right? But now we know why. This is the reason why, right? So this is at the other angle is equal to 180 minus 40.5. I 139.5, right? 139.5. Right? So this is the angle of the obtuse angle over here. Right? This is the measurement 139.5. The 139.5 is the obtuse angle for B, right? Angle B. Okay. Now where is this 139.5? It says 180. So if I go, let me change the color. Let's use green. So I have this 180, right? So start from here. I go 180, and then I have to go back. I have to minus 40.5, so I have to go back 40.5, which is here, right? And that is just a reflection of the same thing, of this point right here. This is just reflection across the y-axis, right? And this angle here, this would also be 40.5, right? This is 40.5. And that makes sense because if you look at the y coordinate of these 2 points, since this is just a reflection, the y coordinates of these 2 points would match, right? So my angle, let me use blue. My angle B, the obtuse angle, is actually this part. This is my B2. Right? This is the obtuse angle. 139.5. And this point here would have the x and y coordinate of the theta that we're talking about here is this 139.5. So this will be cosine of 139.5. 139.5. This is killing me. And the y coordinate would be sine of 139.5. Okay. And if you put that in your calculator, you'll see that the y coordinate, sine of 139.5, matches the sine of 40.5. Right? Which is good because if I put my 139.5 into my B over here, sine of 139.5 will give me the same value of sine of 40.5. Right? So in terms of the sine rule, applying the sine rule, that works. Right? Okay, so this is it. Alright, this is it. The ambiguous triangle examples, they require a lot more thinking, and of course we need to be very familiar with the rules over here. We need to be familiar with the unit circle here in order for us to successfully solve ambiguous triangle problems. Alright, I'll see you guys in the next video. Bye.